So I just got in a new battery from Wattcycle. So this is 48 volt, 105 amp hours, but it's not a server rack battery. This is actually a golf cart battery. But get this, 250 amp BMS. It's got a metal case and you can use it for both golf carts, but you can use it for solar as well. So what we're going to do is kind of the standard test as we normally do. We're going to open it up. We're going to see what comes in it, charge it up, do a capacity test on it, and then tear it completely down and see what's on the inside, see the quality of the build. Now, as you might recall, we actually did a really good review on the Wattcycle server rack battery. Now, that tested out extremely well. It had BYD cells in it, very clean build, massive bus bars. I am hoping that this is the same. So we're going to tear it down, look at it, and see if it is, if it's a quality build like the other one. But then again, until you open it up, you never know. So let's begin. So here's what the battery looks like. So as you can see, you've got your terminals on the side, your positive and your negative. You have your communication port there. You've got your power switch, and then you also have a vent. So if you had a cell that ever vented, it would have a path out of the battery case. It does have some spring-loaded handles up on top, and then also has these very heavy-duty mounts on the bottom. All right, so next we're going to charge it up, and then we'll do the capacity test. Now that the battery capacity test is complete, let's see how it did. One thing to note, the temperature in my shop is 64 degrees, so that may affect the capacity slightly. Here's what it ended up being. So I have the low cutoff at 40 volts, could probably do 39, but 40 should be empty. With that, it ran for 5 hours and 12 minutes, and it pulled 109 amp hours. So for a battery that's rated 105 amp hours, 109 is good, especially with not testing at the optimal temperature and having the cutoff set on the tester. Next thing we're going to do is open it up, and let's see what it looks like on the inside. Okay, so it's your typical 16S configuration. You can see set of cells on one side, and then on the other side, it's got this big old gnarly bus bar connecting them. I like how they have it connected with 2 bolts on each side. It is a very thick copper bar, but they even put a relief in the center of the actual rigid cable, which is nice because as the cells expand and contract, well, this is going to do the same. Now, as all the cells are connected together, you also have that hump. As the cells change based on the charge level, it's going to be able to adjust without breaking the welds. These are nice laser welds that you can see in here. Temperature sensors, you have one on this side, and then you've got another one on this side. Actually, there's 4 temperature sensors. So 1, 2, 3, and 4. And that's kind of nice. Now, what I like about this is you can see the bus bar that connects to the terminal, and they've got one of the temp sensors right there. So if there's any excessive heat, it's going to pick up on that. But wait, there's more. Another temperature sensor actually on the connections. That is cool. Okay, I like that. So it actually has 6. Very nice. T5 and T6. So it's got 6 temperature sensors, and 2 of them are on the bus bars. Everything is torqued down, and you can see that it's glued so it can't loosen up. And then as far as for the cells, it has this nice piece of plastic that kind of wraps around the whole thing and holds it all together to keep the cells compressed. Here's your typical fiber type board divider between each cell. Wiring is nice. I mean, you can see all of the balance leads going across, and each one is labeled with which one that it is. The wires do have a nice wrapping around it, and then it's also zip tied on it. And then for the cells, for the relief, overpressure relief, there's a nice opening that lines up with the cells. For the negative, it's got what appears to be, and I'd have to check this, but looks like two 4-gauge wires on the negative side, which then connect to the BMS. The BMS connects with a nice thick copper bar that connects to each terminal. And on this negative side, since it gets close to the case, they actually insulated it. And here's your positive. Once again, a nice thick copper bar connecting it. Got 2 screws on each one, or 2 bolts, that is. You have your connection here, which is going to connect to your screen, and also the external power button. So you've got your coulometer and your external power. You've got your power button here. BMS goes across the front and pretty much takes up the whole front. But even the hold down assembly that's holding down, the cells and keeping those in place, that's even torqued and glued. And on the top of these batteries, it's got kind of a nice foam board. It's pretty thin, but then the bus bars are up on top of that. So I'm guessing the cells, I don't know how that it's connected. Looks like it just kind of goes up and it's welded in there. Wouldn't be easy to kind of take this apart and read the cells. You'd basically have to destroy the battery doing it. You can see that it's got a thick piece of foam up on top, in which when this clamps down, it's nice and snug. Once again, I think I mentioned before that there's a little vent that's in the front, and then here's where it goes through on the other side. So even though it is sealed, it's got a little vent. So if you had a cell that for some reason depressurized and the gas came out, it would essentially go out this hole. As far as the case thickness, the lid is quite heavy. And it also has, you can't really see this per se, but it's got another fiberboard. This one is black up on top. So that way, if this was ever, kind of crushed, it wouldn't short out the cells. But this is pretty thick gauge steel. Let me show you on the camera, and I'm going to get closer so you can see some things. So you can see the thickness of the steel. I mean, it is a pretty heavy duty case. Let me show you the inside a little bit better. So you can see how that they did the wiring. You can see this big bus bar that I spoke of going across, connecting the two sides together. You see all the cells with their relief. You can see this foam layer here, and then how that is kind of welded through and connects all the cells together. See that wrapper that I spoke of for the wires protecting them, and how everything's zip tied. Here's what holds the cells together. You can see how everything is. I mean, it's a phenomenal build. Here's your positive that I spoke of, a better view. You can see how it's torqued and everything is marked and glued. See, it's got the 6 temp sensors. There's that negative bus bar there. Your positive. BMS. Trying to get a better view of it. Here's kind of the strap. It straps it in all the way around. Not sure on the cells. Like I said, I'd have to destroy the battery to see it, and I really don't want to destroy this one. I'd rather use it. This whole thing kind of reminds me of like an ammo can or something. I mean, to where it's just really thick gauge steel. You can see the mounts to where you can securely mount it. So, yeah, I mean, this thing's made for like a golf cart, but anywhere that you got high vibration, I think this would do quite well. Build quality, you can't get much better than this. Do you guys see anything in here that points that stands out that's not? Let me know, but this is nice. Okay, so now that all the testing is complete, let me give you my overall summary and review. So the battery tested out quite well. It did test over capacity. Please bear in mind that my shop is rather cold. It wasn't tested at the optimal 75 degrees. It was tested below that, but once again, it's still tested above capacity. The build quality on the inside was quite nice. You can see that the cable management was done well. How the batteries were, or the cells that is, were held in was very well done. Everything is torqued down and glued as you would expect. The bus bars look like that they're oversized. That's connecting everything together, especially to the terminal. It has six temperature sensors on it, and two of them are connected right on your primary bus bars that are connected to the battery terminals. So if there's any heat there, it's definitely going to pick that up. So it's just very good build quality. The only thing that I wasn't sure of is the cells, because I'd have to completely just take apart and destroy the battery to do that. And I'm going to make this a test mule with the 250 amp output of this and it being 48 volts. Whenever that I get a new 48 volt inverter is in, this is going to be my test battery. So I'm going to use it for that. The case, very solid. How they have the cells put in there, none of them are touching the sides. So there's that gap and how it's just kind of anchored in the center. You've got the foam at the bottom. You've got the foam board at the top. It's really secure setup. The only negative that I came across, and this could just be me, I'm not sure. I tried using the Wattcycle app. I ran into some issues with it. I wasn't able to connect. I'm not sure if it's the battery or not. It could have just been the app itself. I've seen other people, online that have had some issues with the app just in general. So maybe some improvements there, but the case itself is quite heavy duty. I mean, it's very robust and it's quite thick steel. So highly recommend this for anyone that's looking to get a golf cart battery or just a 48-volt rugged battery in general. And that's it. Thanks again for watching Mike's Solar Garage.